So this is actually sample problem 3C from your book. A hiker walks 25 kilometers from her base camp at 35 south of east. On the second day, she walks 41 kilometers in a direction 65 north of east, at which point she discovers a forest ranger's tower. Determine the magnitude and direction of her resultant displacement between base camp and the ranger's tower. And I gotta say, 41 kilometer day hike, this woman's not messing around. So we're gonna start her off with a dot that will signify where she's starting. That's her base camp. And note that they're being real serious pains in the butt here in that they have given you nothing is aligned on an axis. Everything's at some angle. 35 south of east, so I'm going to draw my little compass rose in here for start. I can visually figure out that that's 45, so I know we're just a little shy of 45, so I'm going to call it about that. Whoops, that didn't help. 25.5 on the first day, which is a pretty good day. That's okay, so there's her first day's travel. Day 2, she walks 41 kilometers, 65 north of east. So I am going to change colors. Well, actually, no, I'm just going to go to a gray for this one. So I'm going to draw another compass rose here. And it's 65 north of east, so there's 45. So splitting the difference again, 20. Probably a little on the wrong side, so we're probably about there. In terms of how precise and accurate you have to be on drawing these, well, you know, in a very real way, you don't. We're not solving these graphically, but if your angles are really terrible, then when you look at your overall triangle, you're going to not be clear on where your angles should be. So this one is 41 kilometers, 65 north of east. So this is 41.0 kilometers, and that's 65 degrees north of east. And I do label my angles on here because it really helps in terms, well, you're going to see where it helps in just a second. So where's our resultant? Well, our resultant is from the tail of the first vector to the head of the last vector, just like it always is. Where's our triangle? I'm going to put in a dotted line. Is this triangle harder than the last one?
A little bit.
A little bit. Yeah, it's not nearly as obvious. But when you look at the resultant, you want to see, you know, you're drawing that overall triangle based on the resultant. Now, to fill in where we get those things, and the picture has to come first here, I want to remind us of something. Okay, so I've written down sort of my basic stuff to remind myself of where the heck I'm going with this up there. So reminding myself that the resultant is the pathetic... Oops, I forgot something and nobody called me on it. There we go. I know you were about to. And that delta x total is equal to delta x1 and delta plus delta x2, and delta y total is equal to delta y1, delta y2. These problems are not hard. They are really just accounting. I'm absolutely serious. They're keeping track and accounting and writing down details. It is organizing your work. They are one of the best things to organize your brain. They're fantastic for that. I actually find these problems rather soothing. I could do them like to calm down if I was upset about something. You'd be amazed. The powerful effect of math to calm for some. Not for all. I know that. My mother would kick me in the shins for saying such a thing. Okay, so let's find our triangles. Let's concentrate on the first displacement first. Here's a question for you. Is that my first x displacement? Is that also my first x displacement? Can I move a vector parallel to itself? You betcha. So if I go with this one, here's the perk. I get to use the angle that I was given in the problem. I don't have to figure out the complement. Not that that's hard. I mean, we can subtract a number from 90. I think we can manage that. Go Midvale Varsity. Let's get one more shade that's actually distinguishable. A lot of options here. Can I go with pink? As much as I hate pink. So is that my Y one? Okay. Now here's where it gets just a wee bit trickier. Is this my X2? Yes. Is this my Y2? Yes, it is. It is. What's so tricky about this? Why is this more challenging? Well, you don't have to. Not in this one. I mean, you can. There are people who, by habit, do the complements. What's tricky is that when you figure out your total x displacement, you're mentally moving one of your vectors. The other part that's tricky about this, and I'm going to draw the overall triangle separated so that you see this. There's my overall triangle. That pink line, the delta y1, cancels out part of the delta y2. So in other words, she went south, and then the second day she hiked back north. So she's not as far north as she would have been had she stayed parallel with her base camp, which is fine. She's seeing the woods and having fun and kicking some serious butt, hiking 41 kilometers a day. But what that means is, and here's where I also usually do a little trick for myself. I'm going to draw little arrows over these. If I'm color coordinating this on my paper, if I'm using colored pencils or highlighters, I will use the color that I'm using. If you're very visually oriented and a color user, that reminds me that when I add those components on my y's, my delta y1 has to be negative. And it's conveniently enough Cartesian negative, so it doesn't cause a whole lot of scramble in my brain. Okay, let's get some stuff down on paper in terms of what those component pieces are. Okay, so I've got these set aside. Easy enough to put in numbers. Let's do that real quick. So we have a delta x1 value. Let's get our delta y1 value. Okay, so we've got 20 and change kilometers east, 14.6, etc. kilometers south, and that's our first day of travel, so that's displacement 1. I'm going to set those aside. And now I'm going to handle my y's. Oh, no, that's, okay, never mind. Duh. Okay, that was my x and y for the first day of travel. Okay, so now let's handle the second day of travel. Sorry about that. So delta x2 equals d2. Which trig function? Go ahead.
I have a question.
Okay, so what trig function will get you the x displacement on that second day? Still cosine. Now be careful. I had a student once, right about this point, who said, oh, so x is always cosine. No, it's not. Draw the picture. Do your little arrows. And let's just get the expression set up for delta y2. That is d2. And if we look at this, it's obviously sine theta 2. And make sure you use those subscripts. They're really quite helpful. As we go and you get more and more pieces that have to fit together, those subscripts are going to kind of save your life. Like I said, this is not difficult. It's just bookkeeping. But it's a lot of bookkeeping. Okay, so I've got my values in there for my delta, my displacement on day 2 on the X and the Y. We were going 17 and change kilometers east, 37 and change kilometers to the north. So now let's plug it all into the Pythagorean theorem. Before we plug them in, I'm going to encourage you on any test, because I try to give as many points as possible. Literally do this. Show me the X, the Y, and then show me delta X total equals 20.88 ... that way, plus 17.327 ... that way. Delta X total equals, remember, do not round. Delta Y total equals, here's where you got to be careful. I'm going to put this in as negative 14.62619 plus 37.15, etc. What do I get for a total here? Finish this on your own. Try it. Tomorrow we'll discuss it, and I'll give you some time to work on the 3C stuff. Have a good day, folks.